Hello everyone. As you can see on the screen, this is your favorite food. Now, what this has connection with chemistry? The very first thing that happens when you get the smell of food, you are pulled towards the kitchen, isn't it? And exactly the same thing has happened with these three people, but it has happened with different intensities, okay? But the core concept is that whenever you get smell of the food, you run towards the kitchen. Means this is a concept which tells us that something is pulled, yes? So in this case, it is going to be electrons. So now who will be pulling the electrons? Definitely the electronegative atoms, or in other words, you can say the electron withdrawing groups, and these are the electron withdrawing groups. So it can be an halogen, it can be NO2, that's nitro, cyanide, acid, all these are electron withdrawing groups. Now, these electron withdrawing groups exhibit -I effect, which is also called as negative inductive effect. Now, let us try to understand this with the help of an example. So here, there are three persons, one sitting in the kitchen, one in the hall, and one in the balcony. So the one sitting in the kitchen will get the strongest smell as he is nearest to the food. The one sitting in the hall will get little smell, and the one in the balcony will get very, very little smell as he is far from the food. Now, what if I draw carbon atoms over here? So let us try to understand this with the help of actual chemistry. So here I'm going to draw a carbon chain. And before that, I'm going to draw an electronegative atom. So in this case, let us consider halogen, okay? And then C1, C2, C3 and C4. Alright, so the same story is going to take place over here as well. This is the electronegative atom. The food is nothing but the electronegative atom, yes, or the electron withdrawing group. So this will pull the sigma electrons towards itself, okay, thereby C1 will get a partial positive charge, okay. Similarly, C1 will pull the sigma electrons towards itself from the bond between C1 and C2, thereby C2 will acquire a partial positive charge which is even smaller than C1. Okay, so C2 will acquire a partial positive charge which is smaller than C1. Similarly, C3 will acquire even smaller charge. Okay, and after C3, the effect will vanish. All right. So this is how the inductive effect works. So an electronegative atom pulls the electrons. Okay, it pulls the electrons from the nearest carbon, but the effect becomes weaker as we move further along the carbon chain. So when you move far from the carbon chain, the effect becomes weaker. Alright, so that was about -I effect. So I hope you liked this. If you want to understand +I effect, watch my next video.